Okay, so this is section 3.6 for Math 9, and this is the last lesson for chapter 3, okay? So this lesson is about how do you do like BEDMAS when you have like rational numbers, okay? So again, BEDMAS is like about, order of operation. So B stands for brackets, E is exponents, D and M is divide and multiply, A and S is add and subtract. Okay. So this lesson is about how do you, do order of operation whenever you have rational numbers. Okay. Here we go. So if there's more than one operation and expression, you need to simplify the expression using the order of operation. Okay. So again, B is brackets, E is exponents, D and M is divide and multiply, and you do these two from left to right. Okay, and then add and subtract is what you do last, and again you go from left to right. Okay, so use an expression and you have two operations. The x means you multiply, this line here means you subtract. So you decide which one do you do first. Do you multiply these two fractions first, or do you subtract this 2/3 at the very end last? So again, since multiply comes before adding, subtracting, so you would multiply these two first, and then when you're done, you subtract 2/3. Okay, so here we go. So let's multiply these two. Okay, so when you multiply two fractions, you have to simplify them. Okay, so 14 and 21, you can cancel them both by 7, so this becomes a 2 and that becomes a 3. And then the 15 and 36, you can divide them both by 3, this becomes a 5 and that becomes a 12. Okay, so you simplify those fractions, looking for common factors between top and bottom. And then afterwards, you look at the 3 and the 12, you can cancel them, right? So 3 and 12, they divide both by 3, so it becomes a 1 and a 4. Okay, so I'll erase all this, so this way you can see the animation. So again, according to BEDMAS, you multiply the two fractions on the left first. So 2 and 3, the 15 and 36, so 5 and 12. And then the 3 and the 12, you cancel them out, you get 1 and 4. Okay, so now you have like 5 and 1 on top, 2 and 4 on the bottom, so you get like 5 times 1 over 2 times 4. And then you minus the 2/3, so this becomes 5 over 8 minus 2 over 3. So when you subtract these two fractions, you get a common denominator over 24. So then you go, okay, 8 times what gives 24? The answer is 3. So you take the top number, you multiply by 3, you get 15. 3 times what gives you 24, you get 8. So 2 times 8 is 16. So when you subtract them, you get negative 1 over 24. Okay. So here's the first example on using order of operation for simplifying, fractions. So here's your next slide. Okay. So what I want you to do is, you can try these two first. Again, simplify these two expressions using the order of operation. So if you want, you can pause the video here, or you can continue on. We can do this example together. Okay, so either way, it's up to you. So again, here we go, 0.9. So what I'm going to do is I'm going to turn each of these rational number into fractions first. So 0.9 is like 9 over 10 minus 0.6, which is like 3 over 5, times 7.5. 7.5 is like 15 and half of 15. And 0.4 is like 2 over 5. Okay, so erase all this, so it looks like this. Okay, so those are the fractions. And again, you have a minus sign, a multiplication, and a plus sign. So if you're using the order of operation, you got to multiply these two fractions first. Okay, so then I'll cancel out whatever can cancel. So 5 and 15 becomes 1 and 3. So there we go. And then so you have 9 over 10 minus 3 over 3 on top and 1 times 2 in the bottom, and then plus 2/5. So I'll simplify this part. It becomes 9 over 2. Okay. Now you look for a common denominator. So this is 10, that's 2, and it's 5. And so your lowest common denominator is 10. So this is like over 10, minus over 10, plus over 10. So this is going to be a 9, stays the same. And the second one is, you see how this is a 2 before? It became a 10. So now you're going to multiply the top by 5, so you get 45. And then this is a 5, it became a 10, so you multiply by 2, so the 2 becomes a 4 like that. Okay, so there we go. And after this, when you have a common denominator, subtract, you have a minus sign and a plus sign, right? So whenever you have the adding, subtracting, you go from left to right. So you go 9 minus 45 first. So you get, anyways, I'll look this up. So you get negative 36 over 10, and then you plus 4 over 10. So now you go negative 36 over 10 plus, 4 over 10, you get negative 32 over 10. Okay, which is the answer that you saw there. Okay, so maybe you can pause the lesson right now and let students try the second example. Okay, so here we go, pause it, and then you wait like 3 minutes and then let people try. Then we'll play the video again, okay? So anyways, I'm just gonna continue right now since I'm just recording the video. So 0.3 repeating, this is like 1/3, and then it's being squared, and it was divided by 0.2 repeating, that's like 2 over 9, minus, again this is 1/3, and then plus 1/2. Okay, so it becomes that. Oops. All right. And then so this square sign means you go 1/3 times itself. Okay, just in case people get confused. So 1/3 to the power 2, that becomes 1/9. So like 1/3 times 1/3 divided by 2 over 9 minus whatever this bracket is. So again, you have two brackets, and that's always the first step. You got to simplify each of those brackets first because of BEDMAS. So 1/3 times 1/3 is 1/9. This part over here is like 1/3 plus half. So you get a common denominator of 6. Okay, so here we go. So it becomes 1/9 times. So again, this is division, right? So I'm going to flip this part. So it becomes 9/2, and then minus. So the brackets part over here becomes 1/3 becomes 2/6. 1/2 becomes 3/6. Okay, so I have to simplify this part first before I can subtract it afterwards. Okay, so there's the brackets. I've taken care of the exponents. Now you're going to multiply these two parts. Okay, so the 9 and 9 cancel out, so you get 1/1. So 1/2. The bracket part over here, that becomes 5/6. And now you have a minus sign, and the minus sign is done at the very end. Okay, so and the reason why I can multiply this part before I simplify the brackets is because they're separated by the minus sign. So that means that while you're doing this part, you can just multiply with the other stuff because it's not affecting each other yet. So after this, at the very last step, this is over half. No, over 2, this is 5/6. Let's get common denominator of over 6. So this becomes 3/6 minus 5/6. Gives you negative 2/6, which is negative 1/3. Excuse me. Okay. Anyways, here we go. Next slide. So this one here, again, give students a few seconds to try this first. And when they're done, we can play the lesson. Okay. So anyways, I'm just going to continue on. So negative 2.75 is negative, let me see, 4, 8, 12. So negative 11/4. And then times 14/10. And then divide this by negative 3/2. So right now you have two operations, multiply and divide, and put this in brackets. Okay. So after this, I would simplify, these two fractions. So cancel. It becomes 2 and a 7. And so altogether this becomes negative 11 times 7/20. And then this is division, so I'm going to change it to multiplication. Times it by 2/3. Okay. So this becomes negative 77. And then there's a negative 3 on the bottom. So the negative signs cancel out. The 2 and the 20 cancel out, it becomes 1 and a 10. So afterwards, this becomes 77/30. Again, they're supposed to be both negative. Since the negative divided by negative is positive, you keep your answer like this. Okay, 77/30. Okay, you can pause this part. Let students try again. Okay, so again, I'm going to change each of these into a fraction. So 0.2 is 2/5 being squared. Plus, no, 0.5 is half, so 1/2 squared minus, no, 0.3 is like 3, how about, 3 over 10 squared, and then I'm going to subtract this part. 4.7 minus 4.2 is 0.5, like that. Okay. So I'm going to square each of these fractions. So 2 over 5 squared is 4 over 25, and then 1 over 2 squared is 1 over 4, minus, so this part becomes 3 over 10 squared is 9 over 100, and then the 0.5 is 1 over 2. Okay. So you look at these numbers, and then you go, okay, what's my lowest common denominator? Okay. So 25 and 4 and 100. So I'm going to change everything over 100. So over 100 plus over 100 minus 9 over 100. And there's a half there. Oh, darn it. So 100 won't work. So I'm going to change this to a 200. Okay, so this is 200. This is 200. And that's also 200. Okay. And so here we go. So 25 times 8 equals 200. So 4 times 8 is 32. 4 times 50 is 200. So 1 times 50 is 50. So now I just, you have an adding and subtracting sign. So my operation will be I add first and then I minus. Okay. So over 200. 32 plus 50 is 82. So 82 minus 9. Okay. So 82 minus 9 will then be 73. Okay, so 73 over 200, and that will be a final answer. So this next slide you're going to be seeing, okay, in case anybody needs to copy this. So next slide you're looking now, okay, is when would you use these order of operation with rational numbers? Okay, so whenever you're converting from Fahrenheit to Celsius, like temperature conversion, you're going to be dealing with a lot of rational numbers. So Fahrenheit is used for measuring temperature. It's often used in the States, and then in Canada we use Celsius. Okay, so here are two thermometers. So 0 degrees Celsius is like 32 Fahrenheit. That's when things start freezing, and then the boiling temperature is 100 degrees Celsius, and in Fahrenheit it will be 212. Okay, so a lot of times you got to be able to go back and forth. Whenever you're baking, usually it's in Fahrenheit, and then when you're watching the news about how hot something is, in terms of the weather, you would be using Celsius. Another thing is fuel consumption with vehicles. And how much gas is being used to drive 100 kilometers. That's the rate of consumption with most vehicles. So a smart car like this would use very little vehicle. Sports car like this, BMW would probably use a lot more gas. Okay. Calculating rental costs for a car or a building. Anything that has to do with science, you're going to be dealing with order of operation all the time. Okay, and I'm going to show you some formulas later on. You can look at yourself. The last thing is finance. I'm going to give you an example afterwards. Like, if you invest $1,000, how much would you get back in 10 years, depending on your interest. Okay, and even just by looking at this chart, this is a chart for a stock that you can buy, and look at these numbers. You can see how they're all just rational numbers. Okay, so numbers appear almost everything you do. Okay, so here we go. First example. Here's an equation how you would convert from Fahrenheit to Celsius. Okay, I think I went over this one class, but anyways, so what I want you to do is, let's say if you have 50 degrees Fahrenheit and you want to convert in Celsius, and here's the formula. Okay, so the way to do it is F stands for Fahrenheit. So what you do is, whenever you have the Fahrenheit in temperature, you plug it into this number here, and then you use this formula, you simplify it, and then it will give you the temperature in Celsius. Okay, so again, you can pause the example if you like, or you can just keep watching if you want. Okay, so now what you do is F is 50, right? Because you have 50 degrees in Fahrenheit and you want to convert in Celsius. So the F becomes 50. Now you have to use the order of operation, so you minus what's inside the bracket first, and then you multiply by the fraction. Okay, so 50 minus 32 is 18. And so 18 times 5 over 9, and so the 18 and the 9 cancels each other out. Okay, so this cancel becomes 1 and 2. So now you have 5 times 2 over 1, which is 10 degrees Celsius. Okay, let's do an example. Okay, so 50 degrees Fahrenheit is equal to 10 degrees Celsius. All right. Okay, so this one's about the rate in liters per 100 kilometers. So when people buy cars, they want to find out how efficient their vehicle is, okay? How much gas do I need to use in order to drive 100 kilometers? So this is a BMW XI. It's a nice car. I have one of these. And so you're asked to solve for R, okay? R again is the rate in liters, okay? So here's the formula, okay? So this formula, the way it works is F is the fraction of the driving on what fraction of 100 kilometers is being driven on the highway, okay? And so what you do is find the value of R when 40% of the driving is on the highway. So this is F, 40%, okay? So 40% of that 100 kilometers is going to be spent on the highway. And the reason why this matters is because when you're driving on the highway, you're using less gas because there's less stopping and going. You don't need to accelerate and stop as much. Whereas in the city, you have to stop because of traffic and so on. Whereas the highway, you're just coasting on a certain speed, okay? Anyway, here's the formula. So you want to find the rate of consumption in liters per 100 kilometers. So here's F. So F is 40%, so you get 4 over 10. And so after this, I would simplify this equation. Again, you can pause here if you like. You can do the math yourself, or we can just continue. The 4 and 6 can cancel each other out. Okay, so I'll just show the step. So the 4 and the 6 becomes 3 and 2. And then the 2 and the 10, you get 1 and 5. Okay, so 31 times 1 over 3 times 5. So you get, we'll just keep it like this. Here, 2 and 10. Okay. Anyways, so 31 times 2 is 62. 3 times 10 is 30. And I guess we kept it this way because, this denominator is 4. Anyhow, so you have negative 62 over 30 plus 33 over 4. You get a common denominator of 60. So 30 times 2 is 60. So 62 times 2 is 124. 4 times 15 is 60. So 33 times 15 is 495. So now you take this fraction, which is negative, you add that one, so it's like 495 minus 124, and you get 371 over 60. Now if you take a calculator and divide this, you get something closer to like 6.18333 liters per 100 kilometers. So that means is it will require 6.18 liters of gas to drive 100 kilometers if you're driving on the highway 40% of the time. Okay, and this only works for this vehicle. Okay, if you're driving a smart car, it will probably be maybe 3 liters, of gas instead. Okay. Okay, so here's the last example, and this one's about money. Okay, so this is about investing. Here's this formula. What it talks about is, hey, how much money do you earn, accumulate, if you deposit, or invest P amount of money. So P stands for how much money you put in. R over here is your interest rate. How much interest do you get? So the higher the amount of interest you get, the better it is, okay? T is the number of years. T could be 5 years, 10 years, whatever, okay? And then N is actually an important thing. You won't actually learn this in grade 9, but N stands for number of compounds in a year, okay? So again, the higher the value of N, the better it is, okay? More compound means that your money is generated a lot faster. Anyhow, let's read the question, okay? So P is a principal, R is interest rate, N is the number of compounds in a year, and T is the number of years, okay? So what I want you to do is read this next part and figure what the P, R, and N, and T stands for, okay? So if $1,000 is invested for 10 years, compounded 4 times a year at 7% interest, what will the value be when the investment matures? So matures means that after 10 years. So let's go through each of these. Okay, what is P? P is how much money you invested, and that's $1,000. So P is $1,000. Okay. R is the interest rate, and it says right here that it's 7% interest, so R would then be 0.07. Okay, and there's a number of compounds in a year. Okay, so if it's compounded monthly, it's 12 times a year, but right now it says compounded 4 times a year. That means that N would be 4. Okay, last thing is, hey, how long am I investing it for? And it says right here 10 years, so therefore T will be 10. Okay, so last step now is you plug everything into the formula, and what it will do is tell you how much money you have at the end of it. Okay, so A is equal to 1,000, which is P. Now your big giant bracket, 1 plus, so this top part will be 0.07, and the bottom value will be 4. All to the power of 4 times 10. Okay, so this part is the exponent, N times T. Okay, so again, order of operation is you have to do what's in the bracket, simplify what's in the bracket first. So 0.07 divided by 4 plus 1. And what you want to do is plug this into your calculator. Just try it first, okay? And see if it gives you the same value. So 1,000 times 1.0175. See if this gives you the same thing, okay? So you take this 0.07 divided by 4 first, and then you add the 1, okay? And then 4 times 10 is 40, so the exponent is 40, okay? So now you have two operations. Do you go 1,000 multiplied by this base first? Or do you go like 1.0175 to the power of 40, okay? And the answer is you do the to the power of 40 first, because this is the exponent, okay? So you got to simplify this exponent first. So 1.0175 to the power of 40 gives you one big giant number, like, no, actually no, it gives you a small value. 2.0015, whatever, okay? So small decimal value of 2.0 something. You times it by 1,000. Now it gives you $2,001.60. So what that means is if you invest, $1,000 in the bank for 10 years at 7% interest rate, the amount of money that you have will now double. Okay, so whatever you put in, now it's over 2 times what you put in. So the investment will double in 10 years at 7% interest rate. All right, we are now done. This is it. Have a good day.